So I have dt, distance in meter, and I have distance in meter, time is in second. So I have -1, 0, 1, 2, 3, and 4. This is position, this is time. Position is distance. The SI unit for distance is meter, and the SI unit for time is second. The trip was 10 seconds long. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Second long. We remind us this is 0. Very important. We remind ourselves that this is 0. Okay. So the object was from, let's say, from 2 to, yep. So from 0 to 3 seconds, object was at 2 meters. From 3 to 4 seconds, object move up from 2 meters to 4 meters. From 4 to 5 seconds, object moved down from 4 to 3. From 5 to 7 seconds, object stayed at 3 meters. From 7 to 10 seconds, object moved backward to all the way -1 meter. So we can divide this graph in 5 sections. This is 1, this is 2, this is 3, this is 4, and this is 5. So we can call it A, we can call it B, we can call it C, we can call it D, we can call it E. 1, 2, 3, 4, 5. Now, what I ask you to do, I ask you to find the displacement in each section and velocity in each section. So let's do that. A, B, C, D, and E. I ask you to find displacement in each section and velocity in each section. So displacement, this is dt graph. So displacement is df minus di. So df for section A is df. So this is 4 meter, this is 3 meter, this is 2 meter, this is 1 meter, this is 0 meter, and this is -1 meter. So df for section A is 2 meter minus di is also 2 meters. So it's 0. Now let's do the B. Section B, the df is 4 meter and di is 2 meters. So it's 2 meter. For C, we're done with A and B. Now we're going to see df. We're going to point our finger over here and we look at the y-axis and we see 3 meters. We're going to write 3 meters and the di where it is started, and we're going to see y-axis and we see 4 meters. So 3 meter minus 4 meters is -1 meter. Now we're going to find D. D final is 3. D initial is also 3. So this is 0 meter. Now we're going to do the E. At E, D final, you're going to look at the y-axis is -1, and you're going to find the DI. DI you're going to look at here, minus 3 meter. Minus 1 meter minus 3 meter is minus 4 meters. So you're going to write minus 4 meters. We're done with the displacement. Now we try to find the velocity. Okay, so the velocity is I'm going to write the formula for the velocity. Is del df minus di tf minus ti. Df minus di is actually delta d change of displacement. So velocity in section A right here is delta d, or change of displacement. We already found that in section A. This is 0. Tf, so 3 minus 0. This is 0. So velocity is 0. B, section B. We already have that. We already have 2 meters. So we're gonna put 2 meters, and 4 minus 3 is 1 second. So 2 meters per second. C, let's do C. We already have C in -1 meter, and C is 5 minus 4. Wow. This is -1 meter per second. -1 meter per second. Now we're gonna do D, and D we already have 0 over here. So 0 over 7 minus 5, 2 seconds, which is 0 seconds. Now we're gonna do the final one, E. E, we already have that, -4 meters. 10 minus 7 is 3 seconds. So -4 over 3, -4 over 3 meters per second. Now what I wanted you to find, I wanted you to find the displacement over the entire trip. So this is A, this was B. Displacement over entire trip. What was the displacement over the entire trip? It's very simple. You add them up. So you write A plus B plus C plus D plus. So A is 0 plus 2 meters plus -1 meter plus 0 minus 4 meters, which is minus plus 2 meters minus 5 meters. This is minus 3 meters. Okay. So the average, the displacement over the entire trip is -3 meters. Now the final question that I ask you to find is the average velocity. So see, average velocity over entire trip. Average velocity over entire trip. How can you find that? You already found the average velocity, the displacement over the entire trip, which is -3 meters. So average velocity is total displacement times the time. So the time. Total displacement is -3 meters, and the time is 10 seconds. So is -0.3 meters per second. There is other way of doing the same thing. You add them up. If you add them up, you should get the same thing. You should get -0.3. Let's see. So if you write 2 minus 1 minus 4 over 3. You don't have to write 0. 0 is 3. 6 minus 3 minus 4. So 6 minus 7 over 3 minus 1 over 3, which is minus 0.3 meters per second. Another way of doing this is drawing a graph from here to here. So you have 2 points. One point is 0, 2. Other point is 10, -1. So D final minus D initial. D d final minus d initial. So d final is -1 minus 0 and 10 minus 7. Minus 2, so minus 3, so minus 3 over 10 is negative a point 3%. So you can get one way, two way, and three way. So by drawing a diagonal line from beginning to end, you can find the slope of this diagonal line and